Well, it turns out you guys liked that last one on spark plug stuff. So, here's 5 more. Let me show you. So, this is our surface gap plug thing. We've got these 5 here. Okay. So, we've got different surface gap plugs here, which I'll run through. And I kick off the light. I'll show you guys what's going on with these things. So first, we'll do this with it open. Interestingly enough, these are still not showing with the signal. Very odd. So we can kind of see the difference of location when we've got surface gap. Okay, I'm going to start bringing RPM up. Probably should have the cover on for this, but let's just see. It's now 5,000 RPM. So besides the signal showing correct on this one, but not on these two, do we see anything interesting with how these are sparking? Well, we're going to change out these two, just for the heck of it. And we know now that these won't get hot, so that's good. I've already preset depth for a lot of these. This one here needs brought up. And we're going to try this again. Okay, kicking off the light one more time. It's about 6,500 RPM. I think we could see a trend with, again, how these are firing. Very interesting. Okay. Now, one thing I'm noticing here is this is a little bit dull up here, and this down here is a very, very bright white. Try to see if I can get a closer shot of that. That versus that. So what are we gaining from this information, right? This plug here, the inside of my hand, so this one right here, is going to be our R7420. Okay, and this is the one that was just in this location. Now this to me has the resistor on it. It's a very quiet plug, and it has a slant tip, which from the last video you guys might have remembered that I mentioned that this is probably getting very warm, and to the point where this might actually have some debris in it, to the point where that this tip might actually start to glow when there is energy on it. Now on the last video, we had a lower resistance Denso version of the same size, same depth. And what this, I believe, is doing is it's creating a kernel in the front here of heat. So where it's pushing out towards the right side in this case, and creating a kernel of heat right here, eventually making a very hot, glowing tip. So while these may be the conventional choice for non-fouling and being the optimal selection, I believe we actually have more power available, or efficiency available rather, on other plugs. So this one here is needing a spacer to get the correct thing, but this is a colder temperature version of one of the popular plugs that I tested last week. So this kind of gets the depth we want for its surface gap style. This is Autolite, and what this is a colder version of the standard Autolite 3932X. This is a 3910X. This is a colder plug, and with a proper size washer, this gets the depth to our 21.5 millimeter that we're aiming for. You'll notice that these two are, when you put the washer on, the exact same height. So this is going to be the same depth into the rotor housing. All right, now why are these three here? This is the plug that Howard Coleman, others, myself are touting as a very, very good option. So you're getting a surface gap design like on last week's stuff, and you're benefiting with having this tip to this clearance here. So our overall clearance being a smaller distance than, for instance, this or this or this, right? This actually has pretty good air gap comparatively. This might be a little bit closer. I will measure this with a set of calipers, or actually a feeler gauge coming up. But this gap here on the R6601-10 is really good. And you guys are seeing the fact that it's dancing around. And because this is plugged, in this case, only 19 millimeters of depth, they're able to machine this down or take off the washer here, the crush washer, to get the depth that we're after for these. Okay, we're after the 21.5 millimeter because that is the optimal depth to get this as close into the rotor housing as possible without having any apex seal, or rather anything protruding into the housing. So you'll see this is a little bit short, which is why these are being machined down on a lathe by Mike to get proper clearancing. Now, I've been finding stuff that's a little bit different. So I've got this right here. Give me 1 second. So this right here is a non-resistor version and proper depth of similar to this. So we are gaining, excuse me, this one is actually, this is about 20 millimeters or 20 and a half. We're gaining this much more inset into the housing. And this is also a colder heat range than the 10. This is about an 11. This guy right here is my golden goose, I think. So we'll see how that goes. And this should be getting us exactly at 21 and a half. Best part is we're getting the best of both worlds from the surface gap technology for Rotary, which is ideal, and the fact that it's cheap, and the fact that it is resistorless, which means that on a CDI system, this is going to be outputting the most power. So we're going to turn the lights off one more time. I'm going to show you guys the difference of these surface gap plugs one more time. Okay, we're now at 9,000 RPM. We're going to look at these. We've got a top view here. A very, very fierce middle plug, which is aiming for, oddly enough, one of those 4 prongs. We've got the equidistant output here of the R6601 heat range 10, And then we've got an almost hyper-focused version. I'm going to zoom in one more shot here. And this is also supposed to be equidistant, but this is a much hotter output. If you look here, seeing a lot of small little kernels, a few more focused ones on this one, and then very focused on this one. See if I can get a little bit tighter on this. I think all of these, every single one of these plugs is going to be very good. So at this given time, I don't think that there's a perfect plug for everyone, right? We're going to have the guys that love these because this doesn't foul. It's $37 a plug. The NGK is just stout, right? It is very, very, very strong to handle a lot of abuse. This slant is adjustable. So if you're somehow blowing out the spark, you can tap this one down, which I think I pre-gapped these. I have to go check. But you'll grab a feeler gauge. You'll get these set to your height that you prefer. And then you'll be set for your needs. There are these very cheap auto lights, which are fantastic. These, I think, are a really good option for everyone. I've taken this plug out to about 515, maybe 530 on pump gas with the mid-size turbo, and works pretty well. I think that Howard Coleman and the others, including myself, are on the right path with the R6601. That is a very good, if you're running Ignition 1A coil, that is my first choice, I think. Now, if you're running CDI, these two, I think, are better. These are a non-resistor plug. This is resistor. This is resistor. This is resistor. So I think that that's kind of doing a disservice to be fighting against the CDI with more resistance than what it needs. And this little tiny cheapy $35 tester will not give us the difference big enough to show across the board what it's supposed to be doing. And can move these around any way, direction, any form. So it's not a matter of what this is outputting or whether these signals are working or whatever that case may be. But what it is doing is it's giving us an idea of how the kernel of flame will be starting. And you guys notice this one is a much more random. This one is finding a focal point, or almost like one or two singular points off of this, what should be equalized setup here. And then this one is also getting almost a focus point, which is weird because, again, we're having the same design on the top. So it's just one of those things where this will take testing. This will take data with years of cars driving on these plugs to get an idea of if they're worthwhile. Now, I do really think we figured out the limitations of spark plug per rotor power for a given system. You know, whether it's factory ignition, LS coils, Ignition 1A smart coils, which I've covered probably 7 times on these, or on this platform for YouTube, or in this case CDI, which is the ultimate in power output. So hope this video helps a little bit. I can give you guys part numbers of these if you need them. I have stockpiles of each one of these plugs, so when this car ends up running, which will be very soon, we're in the process of getting the harness together for the chassis right now. We'll go through a whole build series and testing and R&D and the whole tuning process of this M-tron powered car. So it's going to be pretty exciting. I'll probably make a bunch of videos about setting up the PMU and how I set up every single aspect of the chassis to work in unison and everything's communicating through CAN bus. But for this specific spark plug video, I'm probably going to be running these 2 sets of plugs on this car to get everything set, because these are the perfect depth. They are the non-resistor, and they are a surface gap style plug where I don't have to worry about any sort of slant or something breaking inside the rotor housing and flying around my motor. So when you're going for 40 pounds of boost, go with something that can't break, or if it does break, that can contain itself. So catch you guys in the next one, and hope that helped. Cheers.